Okay, next video on conic sections will be on hyperbola. Oh, I always do that. Sorry about that. Let me start again. Hyperbola. And the general equation, I can never write those lines good either. I'm getting better. X minus h squared over a squared. It's exactly the same as your ellipse formula over b squared equals 1. Now, instead of, whereas an ellipse will be plus there, hyperbola is just minus. Okay, so that is our general form of hyperbola. Again, what does h do? It moves it left and right. The centre left and right. What does k do? It moves it up and down. What does b do? What does a do? It's a little harder to think about as far as a hyperbola, but it's still, a still stretches it in the x direction, and so you can think about it like that, but it's a little bit harder to think about with the hyperbola. Same with the b, it stretches it in the y direction. It's just a little bit harder to think about. So what we'll do is I'll actually explain, just remind you that we did in class the asymptotes. Really important to know these. You should know this off by heart, because you'll need to use it that many times. The asymptotes for this are y minus k, so the y translation is equal to plus or minus b on a, and the x translation x minus h. So that is really important. They will be your two asymptotes for the hyperbola. Really important to know. And also important to note is that the turning points on your hyperbola, so just to remind you, hyperbola will look something like that, where you get that. The turning points, where it sort of turns around there and there, will be at the point, whatever the centre of the hyperbola is, defined by h and k, you move a either way. So it'll go a that way and a that way, and that will be where your turning points are. Okay, so it'll end up being h plus a. Okay, that will be one turning point. The other point will be h minus a. Okay, so there will be your two turning points for any hyperbola. Let's just have a look at that in Desmos. So here's the hyperbola. That's what they look like. And let's have a look at what happens when you move h. What do you think we'll do? Yep, the center of it moves. If you increase it, it moves to the right. If you decrease it, it moves to the left, as you'd expect, left and right. That's all it does. It moves the center of the hyperbola. K moves it up and down. Exactly the same. Every relation will always do this. So a, let's have a look at a. What did I say? That a stretches it in the x direction. You can see it's getting stretched out in the x direction according to a. Okay, and b, what does it do? It should stretch it in the y direction, and you'll see if I increase a, it stretches it in the y direction like that. So that's what the effect of those does. And remember, our asymptotes are given by b over a. So whatever b divided by a is, that gives you the general, that's the gradient of the lines, that the asymptotes for this. So there you go. So let's probably do an example. That's a good thing to do. So next, let's have a look at a quick example. I'm not going to complete the square in there. I've shown you those in the other videos, so I might just go straight to sketching something that's already in sort of good form, because you've seen completing the square enough. You can do that now, no problem. So something like this: x minus 2 squared over 4 minus y minus 3 squared over 9 equals 1. So there's our classic. It's already in the nice form for us. So what do we know? Well, firstly, what's the centre? Let's write down the centre. What's the centre? Well, it'll be whatever that is there. So it'll be, the centre is at 2, 3. H is 2, K is 3. So there's our centre. Easy, no worries. And just because I just remind you, that's a negative there, so it's definitely a hyperbola. If it was a plus, it would be an ellipse. What are our values for a here? Well, I'll just write down a. A, remember, this is a squared here, so a is just the square root of the number under here. And remember, a belongs to x. A belongs to x. So a is 2. B is equal to square root of 9, which is 3. So there's our two values. Why is this helpful? Well, we'll soon see that it's good to write these down because we can figure out what the turning points are, starting at the centre and moving by A left and right, and also we can find our asymptotes. So let's find our asymptotes. Asymptotes. The asymptotes are going to be, remember, y minus k, so I'll write that down, so y minus 3 equals plus or minus b on a, so b is 3, a is 2, so it'll be 3 over 2, and then our x translation. X translation was x minus 2. X minus 2. So there are asymptote equations. It's a little hard to sketch these, so you might want to transfer them into an easier equation to be able to sketch. So let's just do that. We'll expand that and then add the 3, so I've got y equals, it's a little bit nicer. You could do it like this, but anyway, I'll just quickly transfer this into that. So y minus 3 equals plus or minus, if we expand that, 3 over 2x. What's 1.5 times negative 2? Well, that'll be 3 over that. Plus or minus, so maybe I should do both equations, so therefore I'll do the first one, so I'll just, I don't know how to do a razor on this. Anyway, I'll just start again because I don't know how to do a razor. I'll get better at this, I promise. So I'll do the plus one first, so if it's the plus one, you get 3 over 2x, and then if it's positive here, it'll be positive times a negative, so it'll be negative 3. So that's our first equation. I'll just tidy that up. Y equals 3 over 2x. We'll add 3 to both sides and it disappears. So that's our first asymptote. So that's when we've got the positive, that one there. What happens when you get the negative? Well, you'll get y minus 3. That doesn't look weird. Y minus 3 is equal to negative 3 over 2x. What's negative 3 over 2 times negative 2? That'll be positive 3. And then just tidy up there for y, when I add 3 to both sides, negative 3 over 2x plus 6. So there are our two equations, that equation and that equation. And to be honest, you don't always need to do that because I'll show you, it just becomes obvious sometimes what the other one's going to be because they're both symmetrical, both of these two. One has a positive gradient, one has a negative gradient. So there are your two equations, and then we'll quickly sketch them. So where's my space? I'll try and do it here. Sorry. So I'll do it here. There we go. So y equals 3 over 2x will look like something like that. The rise is 3, the run is 2, so it's going to go out sort of through the point 32, and so our line will go like that. It goes through the origin. That's that one there. And this equation here, y equals negative 3 over 2x plus 6, so it's going to go through at 6 through the y-axis. And because we know, what's the centre? Well, the centre is 2, 3, so it's actually that point there. So you know that the asymptote goes through there. The asymptotes always go through the centre. And so that'll help you in, oh, that's terrible, sorry. It'll look like that. So there are your two asymptotes. I'll just label my centre there, 2, 3. 2, 3, right there. And what happens is that, like I said, you start at the centre and it moves by A either side to get your turning point. So that's helpful. So A is equal to 2. We go 2 in this direction, so you're going to go to 4, 3. And that's going to be your turning point on this side. We're going to go on this side. We're going to go 2 in this direction because A is equal to 2. And it'll be right on the axis there of that turning point. And so what it will look like is something like this. It will go up to there and down to there. Similarly, up to there, down to there. Whoops, shouldn't have gone over the line. Anyway, I'm not very good at this program yet. And so that's your hyperbola there. Label the turning points, label the centre of the graph, and if the question asks you, label the x-intercepts, etc. And that's hyperbola.